Somewhere out there in the cold, uncaring void of space, the universe is quietly plotting your demise, not out of malice, but because the cosmos is a chaotic masterpiece of deadly beauty. From stars that explode with the power of billions of suns, to invisible forces that could rewrite reality in an instant, the universe offers no shortage of creative ways to kill you. This isn't just science fiction, it's science, stretched to its most extreme, poetic, and terrifying limits. These are the most interesting ways to die in the universe. Spaghettification near a black hole. Few deaths are more scary or more fitting for a movie than falling into a black hole. Don't believe what the movie said though. There isn't a whirling drain or a big blast. It's just a spooky, quiet nightmare where the rules of the world start to bend and then break. If you happen to drift too close to a stellar mass black hole, you would go through something called spaghettification, which sounds very strange. It's not a pasta party though. When the tidal forces, the difference in gravity between two places on your body, get so strong that they tear you apart lengthwise, this is called spaghettification. Imagine that the black hole is farther away from your feet than from your head. Your body is stretched into an impossible thin strand by gravity, which pulls harder on your feet than on your head. Following one another, every atom in your body is pulled into a vertical noodle. This goes on until you're no longer a person, but a line of matter spinning into nothingness. It's not just how violent this death is that interests me. It's also how relative it is. From where you stand, you might fall in pretty quickly. But if someone outside of the event horizon watched you, they would see your fall slow down, your body freeze near the horizon, and your picture red shift into nothingness. For them, you're stuck in time, like a ghost on the edge of reality. It keeps getting stranger. It is possible to cross the event horizon of a giant black hole, like the ones in the heart of galaxies, without being torn apart right away. At the edge, the tides are weaker, so you might go past the point of no return, and not even know it until it's too late. Nothing can get away from that point on. Don't scream, not a light, don't say goodbye. Not only does spaghettification mean death, it also means taking things apart. You won't end on a good note. You'd leave this world as a thin thought that spanned space and time, like a gravity thread in the center of the universe. Death by 6,000 kilometers per hour. Wind, the glass storm. Consider living in a faraway, strange world where the sky is a stunning sapphire blue. It would be beautiful, peaceful, and almost soothing. Then picture being flayed alive by it. Some exoplanets are beautiful, but they are also very dangerous, and the atmosphere can be used as a weapon. HD 189733b is a real gas giant that was found only 64 light-years from Earth. There is no fire or radiation in this world that can kill you. It kills with wind. Rapid wind that never stops, filled with glass. Scientists think that the winds on HD 189733b can hit over 6,000 kilometers per hour, which is about 4,000 miles per hour or 5 times the speed of sound. The strongest storms on Earth reach speeds of about 300 kilometers per hour. The weather in this world makes that look like a light breeze. The dangerous part is that these aren't just fast winds. They are full of liquid glass, which is made up of tiny, hot pieces of silicate that have been whipped around in a never-ending storm. You wouldn't just fall down if you were dropped off the edge of the world. You would be torn apart by tiny glass knives moving at speeds as fast as they could cut steel. Your skin would be ripped off right away, and then muscle, then bone. Everywhere you looked, there was a new attack, and there was nowhere to hide. It was a global, never-ending storm. The opposite side of the world is very hot, and the other side is very cold. This is how science works. HD 189733b is tidally locked, which means that one side always faces its star, and the other side stays in shadow. Strong winds blow from the day side to the night side because of this change in temperature. And those winds bring rocks that have been vaporized and then turn back into glass in the air. Then the planet throws them sideways through anything that dares be on its surface. What would happen here is death would not roar, it would whimper. The noise of broken glass cutting through the air. The wind's shriek was so sharp it could erase you molecule by molecule. There were no big blasts. There was only quiet, careful destruction in a beautiful, dying sky. Gamma-ray burst vaporization. A gamma-ray burst is one of the fastest and cruelest ways to die in the vast stage of the universe. 1 minute you're looking up at a clear night sky, and the next your oxygen is gone, your DNA is broken up, and the Earth is getting hot from the inside out. Not a fireball, not a warning. It's just a flash of pure, high-energy radiation that hurts more than the sun could ever hope to do. Gamma-ray bursts, GRBs, may be the strongest blasts seen since the Big Bang. They come from terrible cosmic events like neutron stars combining or huge stars collapsing into black holes. During one of these titanic moments, 2 focused beams of gamma rays can shoot out from the poles of the dead star. These beams aren't very big. They look like lasers. However, if your world is in its path, even if it is thousands of light years away, it could mean quick death. The energy in a GRB is concentrated into a narrow beam, and that makes it all the more lethal. A single 2-second burst can release more energy than our sun will emit in its entire 10 billion year lifetime. And what does that mean for anything in its way? Atmospheres stripped off in seconds, ozone layers annihilated, a wave of radiation that doesn't burn your skin. It vaporizes it at the molecular level. The surface of your planet would be sterilized, the biosphere fried like an egg under a fusion torch. What makes GRBs so chilling is that they don't come from within your planet, or even your solar system. They're extraterrestrial snipers, targeting life from across the galaxy. Earth itself has likely been hit by one in the past. Some scientists believe that a GRB may have triggered one of Earth's mass extinction events around 440 million years ago. And you wouldn't see it coming. No glowing build-up, no screaming skies, just a sudden, silent, invisible death ray. And then the lights go out forever. There is only one person in the universe who can kill people quickly and efficiently. The gamma-ray burst. It kills from space and doesn't even leave a body behind. Neutron star collision shockwave. 2 of the densest things in the universe hit each other. As a result, there will be a strong gravity scream, a radioactive blast, and a shockwave that can break atoms apart. You are about to turn into space dust if you are anywhere near, and nearby could mean dozens of light years away. When neutron stars crash into each other, it's the slowest possible wreck in the universe. Neutron stars are what's left over when big stars die and fall apart, squeezing their mass into a sphere only a few kilometers across. Imagine putting the sun's entire mass into a city the size of Manhattan. Now picture 2 of these huge spheres hurtling toward each other at a speed much slower than light. The energy they release when they hit is beyond the end of the world. The gravitational wave is the first one. It is a ripple in space-time. After that, gamma rays and X-rays shoot out in a burst of high-energy radiation. Then there was the shock wave, which was like a wave of raw matter and energy that went through the galaxy. You won't have time to figure out what hit you if you're in a nearby world. Everything will be taken away from you. The temperature will rise to over 1,000 degrees. You won't just die. You'll stop existing as you are now. A kilonova is what's left behind, which is just as scary. By fusing atomic nuclei together in the chaos, this strange explosion makes heavy elements like gold and platinum. They are screamed into space at millions of kilometers per hour by the blast. Space turns into real shrapnel. It's a pretty one, but it will kill anything living. So far, we've heard the faraway echoes of these crashes through gravitational waves, which are very weak warnings of disaster coming from galaxies very far away. But if one happened too close to Earth, it would probably make it impossible for people to live here, wiping out whole ecosystems faster than you can scream into the void. When neutron stars crash into each other, science fiction and real life meet. They're not just ideas, they have been seen. And they tell us that death doesn't always come from above. Sometimes it comes from inside the bones of stars clashing in silence, before destroying the whole universe. Supernova overkill. A star should always be there, shining brightly in the sky. But some stars explode so brightly when they die that the light from the explosion can light up a whole galaxy. Yes, this is a supernova. If one happens close enough to Earth, it's not just a light show. It will kill everyone on Earth. A big star loses the fight against gravity when it runs out of nuclear fuel. Its center falls apart, crushing atoms and making protons and electrons merge into neutrons. The star's outer layers bounce back and explode outward in an explosion that can release more energy in a few weeks than our sun will in its whole life. You're being hit by what would be the equal of a few octillion nuclear bombs going off at the same time. Around 50 light-years from Earth, a supernova would be the end of the game. The first flash of gamma radiation and X-rays would tear through the atmosphere, killing the ozone layer and exposing the surface to the sun's direct ultraviolet light. After that, there isn't an instant explosion, but a slow, inevitable roast. Plants die, ecosystems break down, a lot of mutations happen. The body is slowly breaking down, so it's not a quick death. And if you're nearby, ozone won't be a problem. There would be no atmosphere at all because of the supernova's radiation and particle storm. All of a sudden, you're breathing. 1 second you're in the empty space of space, and the next you're being burned up by a blast wave, traveling at thousands of kilometers per second. In a strange twist, the things that make up your body, like the iron in your blood and the calcium in your bones, were made in supernovae. Explosions like these are how the world recycles matter. They make things, but they are also great killers. The scariest part. Supernovae don't send out signals. There is no timer or rumble to build them up. In a second, there's a star. 1 minute, the sky is as bright as the sun, and you're already getting very hot inside. Quasar roasting. In the middle of some galaxies, a monster eats. It doesn't do it in silence. It shines so brightly that it can be seen from anywhere in the universe. This is a quasar, which is the light from a giant black hole that is eating matter. And if you happen to be anywhere near one, you won't die quickly or dramatically. It will be slow, constant, and toxic. A slow roast by the brightest star in the world. Supermassive black holes, which are millions or even billions of times the mass of the sun, eat gas, dust, stars, and anything else that gets too close. This makes a quasar. Friction makes this matter heat up as it moves inward, making an accretion disk that gets hotter than the core of most stars. The energy that is released doesn't just go into the black hole. It comes out in the form of light, ultraviolet radiation, X-rays and gamma rays. It's the brightest steady radiation output that we know of in the universe. Now picture yourself living on a planet around a star that gets too close to this eating frenzy. You wouldn't get caught. The radiation would cook you to death. It would be the atmosphere that goes first, because high-energy particles would wipe it out. On top of that, radioactive sickness, DNA damage, and cancer are all very bad. You wouldn't have time to feel pain if you were directly exposed. Your body would break down at the cellular level like flash paper under a blowtorch. But quasars are still dangerous, even if you're not right next door. Their radiation can reach distances of billions of light-years, stopping the birth of stars, ionizing gas clouds, and wiping out whole areas of galaxies. It's death from afar, quiet, beautiful, and inevitable. But quasars are still dangerous even if you're not right next door. Their radiation can reach distances of billions of light-years, stopping the birth of stars, ionizing gas clouds, and wiping out whole areas of galaxies. It's death from afar, quiet, beautiful, and inevitable. If you ever get close to a quasar, don't look up in awe. If you can, run. Because what looks like a directing star could actually be the eye of a vast oven, and you're already inside it. Magnetar pulse annihilation. You've probably never heard of a magnetar. That's because the universe doesn't give them away easily. They're rare, elusive, and hidden among the stars like ticking bombs. But if one ever turned its gaze toward Earth, you'd know its name in your last millisecond of existence. Death by magnetar pulse is one of the most exotic, terrifying, and instantaneous ways the universe could end you. A magnetar is a type of neutron star, already one of the densest objects in the universe. But what sets a magnetar apart is its magnetic field, the most powerful known in nature. To put it in perspective, Earth's magnetic field is about 0.5 Gauss. A fridge magnet is around 50 Gauss. A magnetar's field, roughly a quadrillion Gauss. That's strong enough to twist atomic nuclei, to reshape the very vacuum of space around it. You wouldn't just die near a magnetar, you'd be unmade. Say you are a few 100,000 kilometers away from a magnetar. Your body's very makeup, its atoms, would start to fall apart. The magnetic field would change the shape of the electron clouds in your atoms, which would destroy your chemistry before you could even scream. You wouldn't have seen it coming because magnetars don't always kill. They let out their anger in sudden, random bursts. In December 2004, one such burst from a magnetar over 50,000 light-years away bathed Earth in a brief pulse of gamma rays. It was enough to temporarily ionize Earth's upper atmosphere and knock out satellites. Let that sink in. From halfway across the galaxy, a single magnetar flex nearly disrupted our planet. Now imagine that same burst happening from just a few light-years away. First, your planet's atmosphere is gone. Then comes the radiation, X-rays, gamma rays, and magnetic shock waves that rip through your biosphere. Electronics fail instantly, magnetic fields collapse, the ground itself trembles as molecular bonds are weakened. You wouldn't be burned, you wouldn't be crushed, you'd be scrambled, like a hard drive magnetized into static. Only the hard drive is your biology. And the scariest part, there's no defense, no warning system, no shelter, no escape velocity. Magnetars are quiet, sleeping monsters, and their pulses don't travel with light you can see. Just a flash of invisible death, rewriting chemistry and biology with magnetic force alone. So, if you ever see the sky light up and your electronics flicker for just a moment, it might already be too late. Cosmic string slice. There are cutting blades in the universe. They are older than galaxies, faster than light, and sharper than anything we can think of. These are cosmic strings, which are flaws in the theory of space-time. They are smaller than an atom, but have the mass of a rock per centimeter. Maybe even your world if one went through it. You wouldn't even have time to feel it. You would be cut in half by the very blade of creation. Cosmic strings are hypothesized to have formed during the early universe, when it was just fractions of a second old and undergoing rapid phase transitions, like cracks forming in ice as water freezes. These cracks in space-time could stretch across the universe, relics of cosmic symmetry breaking, infinitely long and unimaginably dense, and their defining feature? Tension. Enough tension to snap a planet apart like paper under a guillotine. Now picture this. A string of space matter moves through your solar system a little slower than light. It doesn't shine, it just doesn't hum. There isn't any climate or heat to bother you. It goes right through. For a moment, your world is whole. The next second, there is a clean, quiet cut through the center that cuts through countries, oceans, and people with no opposition. Nothing else would need to be done. The two halves would move apart, crack, and fall apart, sending pieces into space. But it gets weirder. Cosmic strings can also create bizarre gravitational lensing effects. Because they're so dense, they can bend light and distort space around them like invisible threads tugging on reality itself. You might see strange mirages in the sky, duplicate stars, distorted galaxies, long before the string itself arrives. Think of it as the universe glitching before it unzips. Theoretically, if two cosmic strings intersect, or if one forms a closed loop, it can create gravitational wave bursts, strong enough to be picked up by instruments like LIGO. We haven't confirmed their existence yet, but the search is ongoing. And if they do exist, even one wandering into our galactic neighborhood would be a silent executioner unlike anything else in the universe. Falling into a strange matter star. Some stars are so strange that they might not only kill you, but also change your mind. The strange matter star is a made-up object that isn't made of atoms or even neutrons. Instead, it's made of strange quark matter, which is a much stranger substance. If there is such a star and you were to fall into it, you wouldn't just die. In the most concrete and quantum way possible, you would stop being you. To understand the horror, we need to shrink down to the smallest scales. All matter, including you, is made of atoms, which are made of protons and neutrons, which themselves are made of up and down quarks. But there's another type of quark, the strange quark. Under the intense pressure inside a neutron star, it's theoretically possible for some of the neutrons to melt into a soup of up, down, and strange quarks, forming what physicists call strange matter. This is where it gets scary. It's possible that strange stuff can spread. It's possible for a piece of strange matter to turn regular matter into more strange matter atom by atom. It spreads through your body, the ground you're standing on, and even through the Earth itself, like a deadly virus. Your atoms wouldn't be burned or broken if you fell into a strange star. They would be changed into a completely different kind of stuff. You would change into something that you can't recognize. It's cold, dense, aliens. Strange matter is denser than anything but a black hole, so the pressure would crush you right away. You wouldn't be squished into a pancake flat shape. Instead, you would be squished into a very thick mass of particles. Then, they were swallowed. Gone. Still there, in the same way that data that has been scrambled is still data. But not in a way that is like real life. This scenario isn't just science fiction. Some physicists believe that if even a single strangelet, a tiny lump of strange matter, made its way to Earth, it could start converting the planet from the inside out. Total planetary death, no explosion, no heat. Just transformation, quiet and final. So if you ever encounter a star that seems a little too compact, too cold, too perfectly still, run. Or don't, because by the time you get close enough to know, the strange matter may already be rewriting your existence. Vacuum decay, reality implosion. Every breath you take and every law of physics you believe in could be a cosmic dream that is just on the edge of being real. Vacuum collapse is the fastest, quietest, and most certain way for the world to kill you. It wouldn't hurt you. There would be no sound. Because you and everything else would cease to exist in less than a second, not because of an explosion, but because reality itself would be completely changed. Here's the terrifying idea. Our universe might be in a false vacuum state. That means the vacuum of space, the empty fabric that underlies all particles and forces, might not be at its lowest possible energy level. It's stable, but not perfectly stable. Somewhere, deep in the laws of quantum physics, there's a lower energy state that space could drop into, a true vacuum. And if it ever does, the results would be catastrophic on a universal scale. How does it take place? Tunneling quantum bits, a very small area of space, maybe even smaller than a subatomic particle, tunnels into the real vacuum all of a sudden. The rules for this new vacuum are different, but it is more steady. Things like gravity, electricity, and the mass of particles are now being rewritten as laws of nature. This new version of reality starts to spread out at the speed of light, making a death bubble. There isn't any notice, but you can't see it coming because the bubble wall moves faster than light. As soon as you put down your coffee, a new set of physical rules changes the way your molecules are arranged, or even wipes them out. Atoms might not stick together. Physics might not work. Time could even act in different ways. It's not death. At the most basic level, it's written as not existing. Some physicists even suggest that the Higgs field, the very thing that gives particles their mass, might be the weak link in our vacuum stability. Measurements at CERN have hinted, though not confirmed, that our universe might be metastable, meaning this doomsday event is not just possible, but eventually inevitable. It is very unlikely that vacuum loss will happen in our part of space anytime soon. We wouldn't know if it started or not. Don't be afraid, not hurt. It was just sudden and complete silence. If this kind of death has a lyrical side, it's that the end wouldn't come from above or below, but from inside reality. the universe puts its own story to rest and starts a new one. Time dilation starvation. Think about being stuck in a moment that will never end. Not in a figurative sense. You are truly stuck on the edge of time, where each second feels like a lifetime to everyone else. You have reached time dilation starvation, a strange and cruel end caused by time warping near large items. We know that gravity bends time as well as space because of Einstein's theory of general relativity. In places with stronger gravity, time moves more slowly than in places with lighter gravity. This effect is very strong when it's close to something very big, like a black hole. From far away, it would look like you're moving and talking more slowly, like a movie that isn't working right. But what about you? It looks like everything is fine until you realize you're slowly going hungry. Let's say you're on a spaceship hovering just above the event horizon of a supermassive black hole, staying stable through immense propulsion. For every second you experience, hours, days, or even years could pass outside. You drop a tool. It seems to fall normally. You take a breath. But back on Earth, decades might pass. Entire civilizations could rise and fall while you wait for your next sip of water. It's scary that your body doesn't stop. You're hungry. You need to drink. But from your point of view, time seems to be going as it should. You will feel every pain and pang if you run out of food or air. People who don't see time the way you do have already aged, died, or forgotten about you, so no one will come help you when you call. Even worse, too much energy would be needed to move away from the black hole in order to get out of this time trap. More than a planet's worth of fuel would be needed. You're stuck now. A ghost in the past. We used GPS satellites to measure time dilation. In order to be correct, these satellites have to take into account changes in time caused by gravity. When this happens close to a black hole, it changes or ends life. There is no blast or implosion to cause death. Instead, there is a slow loss of mind and body that spans time. Fusion in a white dwarf's core. People often compare white dwarfs to the ashes of dead stars because they are small, thick, and quiet. But hidden inside these star bodies is a pressure cooker full of unburned rage. You wouldn't just be crushed or burned up if you fell into a white dwarf. You might even set it on fire. And by doing that, you'd start one of the worst responses in the universe. An atomic explosion that could destroy an entire solar system. A white dwarf is what remains after a star like our Sun exhausts its nuclear fuel. It sheds its outer layers and leaves behind a hot, dense core roughly the size of Earth, but with the mass of the Sun. The pressure inside a white dwarf is supported by something called electron degeneracy pressure, a weird quantum mechanical rule that says electrons can't be squeezed into the same state. This pressure holds the star up against gravity barely. Now here's the horrifying part. If you added just a little too much extra mass to a white dwarf, say by falling into it, or by dumping more material onto it from a nearby star, you could push it past a critical threshold known as the Chandrasekhar limit, about 1.4 times the mass of our Sun. Degeneracy pressure is no longer enough to hold the star up after that point. When the core falls apart, carbon and oxygen atoms suddenly fuse together, starting a chain reaction that can't be stopped. It's not a bomb. It's a bomb. Another name for the white dwarf is a type Ia supernova. It is one of the largest and strongest explosions ever seen in the world. And you're the spark. Your fall doesn't end in fire or pressure. It ends in a cosmic flashbulb so bright it can be seen across galaxies, a beacon of your final mistake. For a few short weeks, the star outshines entire galaxies. Then, nothing remains but glowing debris and a faint echo across the stars. If you ever want to get close to a white dwarf and look around, know that it's not a quiet graveyard. The weapon is asleep, and your presence could be the sound that wakes it up. Tidal forces of a naked singularity. Even though black holes are scary, they are at least kind enough to hide their threats behind an event horizon, which is a line beyond which no information can get out. What if that veil wasn't there, though? What if the singularity, the infinitely dense core, was open to the world instead of being hidden from it? In this case, A naked singularity is like a scary monster that could kill you in a creative way by breaking you apart from all sides at the same time. There are places in Einstein's general theory of relativity where the math doesn't work as it should. The laws of physics stop making sense at this point because the curve is so big and the gravity is so strong. This point of no return is hidden in black holes by an event horizon. But a naked singularity doesn't have that kind of screen. It's physics without a safety net. A cosmic glitch where the rules of reality might fall apart and cause and effect might not work. Think about getting close to one now. If you don't have an event horizon to protect you, gravity goes crazy. Different parts of your body would feel different amounts of gravitational pull, which is called tidal forces. They wouldn't just stretch you out like they do near a normal black hole. The forces could instead twist, break, and squeeze you at the same time, in ways that don't even make sense. It was possible to pull your atoms apart along one plane, crush them along another, and twist them in ways that were not possible in the first dimension. Time could go around and around, or even go backwards. You wouldn't just die, your parts would be spread out over a place that shouldn't be there. Even worse, the energy radiating from a naked singularity could be infinite. With no event horizon to trap it, the singularity could spit out radiation, matter, and pure chaos. If you were nearby, you might be bombarded with gravitational waves, high-energy particles, or even exotic phenomena we don't yet have words for. Some theories suggest naked singularities could serve as portals to alternate universes or gateways to regions where space and time flip roles, though you wouldn't live long enough to find out. No naked singularities have been seen as of today. They don't exist in real life, and most scientists hope they don't, because if they did, it would mean that the world can be broken. However, if you do happen to come across one, don't expect to die quickly. Expect it to be hard to understand. Drowning in a methane ocean, Titan style. Titan is Saturn's biggest moon and one of the most Earth-like planets in the solar system. It's like Earth if Earth had seas of liquid natural gas, temperatures below -179 degrees Celsius, and air that you can't breathe. Death doesn't happen quickly or powerfully here. It happens slowly, and you can feel the cold getting into your bones and the gas filling your lungs. Titan is a strange alien world. Methane and ethane are fuels that are gases on Earth but flow like water in Titan's deep freeze. This is why it has lakes, rivers, rain and clouds. Kraken Mare or Ligeia Mare are some of Titan's seas. If you fell into one of them, you wouldn't float like you would on Earth. People are less dense than water, but more dense than liquid methane. This means that you would slowly sink, like a ghost going down into icy oil. As your body slips under the hydrocarbon waves, the air, mostly nitrogen with virtually no oxygen, offers no salvation. You can't breathe. Even if you tried, the cold, flammable gas would freeze and suffocate you. Your breath fogs uselessly in a methane mist, and your lungs seize with chemical frostbite. And the temperature? It's so cold that even oxygen would liquefy around you. The pressure is gentle, less than Earth's, but it won't save you from the chill. Let's say you're wearing a standard spacesuit. That might delay death, but Titan's environment is cunningly hostile. Its low gravity, about 14% of Earth's, and thick atmosphere mean that even simple falls become floaty, awkward struggles. The methane seeps into cracks and seals. The cold drains your battery life in minutes. And should your suit fail, your blood wouldn't boil. It would flash freeze solid. You wouldn't shatter like glass, but you'd feel the heat leaving your body in an instant, like being submerged in liquid nitrogen. Your body wouldn't break down even after you died. Titan doesn't have any microbes or warmth for things to break down. You'd stay there for ages, a frozen figure under the strange waves, waiting for someone to find you, or you might never be found at all. Titan's methane seas are a quiet but scary part of the big show of cosmic deaths. No fire, no scary things. It's just you and a lake of liquid gas on a moon that looks like home until you take a breath. Boiling in a Venus-like atmosphere. Even though Venus looks like a beautiful gem in the morning sky, it's not really a planet. Instead, it's more like a hellish world full of acid and pressure, where one of the most horrible deaths in the solar system could happen. Do not worry about your safety if you go to Venus. You will not die. You won't even have time to scream before you're crushed, baked, and broken up. First, the air. Venus's atmosphere is 96% carbon dioxide, thick and suffocating, with a surface pressure 90 times greater than Earth's. That's like being a kilometer underwater, except instead of water, it's hot, toxic gas pressing on you from all directions. Your lungs wouldn't just fail, they'd collapse inward, and any spacecraft or suit not specifically engineered for this environment, flattened like a soda can under a steamroller. The heat comes next. Venus is hotter than Mercury, even though Venus is farther from the Sun. This is because Venus has a thick layer of carbon dioxide that holds heat very well. It is about 475 degrees Celsius, 900 degrees Fahrenheit, on the surface. It's so hot that lead would melt. It would make your eyes boil. Your bones would get black. If your spacesuit could somehow resist pressure, it would still cook you from the inside out. We're not done yet, though. Let the acid rain begin. Sulfuric acid is mixed into Venus's clouds. It condenses high in the sky and rains down, but the acid evaporates before it hits the surface because it is so hot there. Even so, if you were high enough to feel the rain, it would cut right through your skin, your suit, and your sense of self-worth. Even robot landers like the Soviet Venera probes only made it a few hours before they were fried, crushed, and rusted. What about the winds? Super-rotating clouds circle Venus at hundreds of kilometers per hour, mixing acid, heat, and pressure in a way that is very bad for you. If you thought storms were bad, try living in a chemical mixer that was set to roast. It's no wonder scientists describe Venus as the solar system's closest thing to a real-life version of Dante's Inferno. The surface is dark, scorched, and eerily silent, an eternal twilight under crushing clouds. So yes, Venus may be Earth's twin in size, but it is most definitely not a sibling in spirit. It's the murderous older cousin, smiling through a veil of acid clouds, waiting to turn curiosity into instant cremation. Shattered on a pulsar planet. This is like living on a world that circles a cosmic lighthouse. But the light isn't gentle beams. It's a torrent of dangerous radiation that flashes in your face every second. If you step foot on the surface of a pulsar planet, it would be like being in a high-speed microwave with teeth. Every time the clock strikes, there is a blast of electromagnetic death. Pulsars are the very dense remains of very large stars that went supernova. They are basically rotating neutron stars. They are only 20 kilometers across, but they have more mass than the Sun and spin at very high speeds, up to hundreds of times per second. From their magnetic poles, they send out strong beams of radiation that move through space like strobe lights in space. Now, picture a planet that is stuck around one of these monsters. Some of these planets have been found. They circle pulsars like PSRB 1257 plus 12, which was one of the first known systems of planets outside of our solar system. These places are real, and they're very scary. As the pulsar's beam moves across its planet, which can happen dozens or even hundreds of times per second, it sends out a flood of X-rays and gamma rays that are strong enough to kill everything on the surface of a planet. There is no environment that could handle it. You couldn't be safe in a magnetic field. If you stood on such a world, you would be hit over and over with radiation waves strong enough to tear your DNA apart molecule by molecule without stopping. It would be unbearably painful, but that's not all. Pulsars create very strong magnetic and gravitational pulls. There may be tidal forces on the surface of a pulsar planet that break the crust apart, causing big earthquakes and geological upheaval. The pulsar's atmosphere could cause dangerous currents to flow through any metal you wear, which could fry your electronics and maybe even you. Even if you buried yourself beneath the surface, the radiation would still reach you. Gamma rays don't care about your bunker. They'd pass through meters of rock like sunlight through a window, turning your organs to mush and your nervous system into static. A day on a pulsar planet wouldn't feel like life. It would feel like being inside a strobe-lit torture chamber where the universe plays you like a drum until your body can't take another beat. Suffocating in a carbon dioxide ice world. Some worlds aren't burning hells or radioactive fears. They're frozen tombs that are so still that even the air freezes over. Welcome to a world made of carbon dioxide ice. It is so cold and the air is so strange here that every breath feels like you're going to suffocate. Carbon dioxide is a gas that we breathe out and a small part of the Earth's atmosphere. But on some very far-away exoplanets, like those that are very close to their stars or that orbit cold, dim red dwarfs, CO2 can turn into snow and ice, covering the surface with a creepy frost. If you picture a world that looks like Antarctica, but the snow isn't water and the air is sinking into the ground. As soon as you step off your ship, you'll see nothing. It was so quiet that it was like the world was too cold for the weather. There was no sound or wind. The ground is very smooth, the sky is still, and it's so cold that CO2 freezes at 78, 5 degrees Celsius, 109, 3 degrees Fahrenheit. And that's when it's warm here in the day. You take a deep breath, try to do it, but there is no air. There is only the thin, suffocating silence of pure carbon dioxide. No matter how hard your lungs try, they can't use the gas that they take in. It's so cold and low outside that your helmet could crack and your breath would freeze in the air, even if you're wearing a suit. Let's say you hit your head or fall through a layer of frozen CO2. The cold doesn't just freeze your skin, it also kills your cells, freezing the water in your body and making your organs weak. Depending on how badly the world responds to you, you could suffocate in minutes or break apart in seconds. And the scenery doesn't get better. The world stays the same. There aren't any earthquakes, waves, or day-night cycles to make things interesting. It's like being stuck in a cosmic freezer that's happy to freeze you to death right where you are, with your last breath turning to frozen gas. Death here is slow, clinical, and emotionless. Not a punishment, but a consequence of existing in a place where the very idea of air has frozen solid and where life was never meant to begin. Crystallized to death in a diamond planet. Envision a world where the ground is not rock or dirt, but diamond. Solid, shiny carbon that covers the whole world. It sounds like heaven. Not quite. Welcome to the cold, sparkling terror of a diamond world, where death and beauty are made of the same crystal. 55 Cancri E is a popular possibility for such a world. It is a super-Earth that orbits a star only 40 light-years away and is about twice as big as Earth and 8 times as heavy. Scientists think that a big part of it might be solid carbon, which would make it a planet made of diamonds because of its mass and carbon-rich makeup. Now picture standing on it. The gravity would crush you. Twice as strong as Earth's, possibly more, depending on local conditions. But the real danger isn't the pressure. It's the chemistry and temperature. On one side, the planet is locked facing its star, scorched at a surface temperature of over 2,500 degrees Celsius, 4,500 degrees Fahrenheit, hot enough to melt metal. The other side, perpetual night, with heat radiating away into the vacuum of space. This sharp thermal gradient creates a hostile environment of superheated gases and toxic winds sweeping between hemispheres. If you landed there, you'd be cooked alive before you ever saw the diamond core. But let's pretend you survive that. You burrow down into the planet, through its crust of carbon, and encounter pressures so immense that carbon transforms into its most stable configuration, a massive, gleaming lattice of diamond. As you descend, friction ignites, your suit fails, and your body superheats from the inside out. How bad could things get? The crust moves. When that much carbon is put under pressure, it doesn't break like glass. It sends out a shockwave that moves through the crystal faster than sound. In a flash of white light, you'd be gone, and your molecules would be trapped forever in a grave of shining carbon. It's cruelly ironic. Diamonds are very rare, very beautiful, and very valuable on Earth. But on this world, they're common and dangerous. Your final resting place wouldn't be a stone or wood coffin. It would be the size of a planet, and your atoms would be stuck in its grid forever, a lovely grave, a wonderful tomb, and a warning that in the world, even having nice things can kill you. Absorbed by a Bose Einstein star. There are weird stars, and then there are impossible stars, which are made up of things that are so strange they make black holes look normal. The Bose Einstein star is a thought-to-be stellar object that is not made of atoms, but of quantum matter in a single superstate. You wouldn't burn or blow up if you fell into one. You would slowly fall into it, like a thought falling into a dream, and stop existing in any way you can see. We need to learn about Bose-Einstein condensates in order to understand this. Bosons are particles that can lose their individual identities and start acting like a single quantum entity when they are at very low temperatures, just a bit above absolute zero. They meet up, they work together. They turn into a superfluid, which is a ghostly material that doesn't stick to anything and moves without any resistance, going against the rules of physics. Now scale that up to stellar proportions. A Bose-Einstein star, sometimes called a boson star, would be a compact object with no hard surface, no crust, and possibly no event horizon. Instead, it would be a coherent blob of quantum matter, pulsing and shimmering with gravity alone. Fall into one, and you wouldn't feel an impact. There'd be no dramatic crash or explosion. You'd just keep falling. Gravity would draw you inward, but without resistance, without heat, without even friction to tell you something is wrong. You'd sink deeper and deeper into the superfluid core. But the deeper you go, the more your sense of self unravels. Atoms have a neat structure. Matter, on the other hand, acts more like chance than substance inside a Bose-Einstein star. Your cells, your body, and even your particles start to dephase, which means they stop being coherent in a sea of quantum unity. You wouldn't be cut up or destroyed. Your quantum information might instead mix with the cloud and become swallowed, spread out, and impossible to find. There's beauty in this kind of death. It's not painful. It's not violent. It is quiet and clear. You go away instead of exploding, not in fire, but in the quiet collapse of the universe. Not in a spiritual way, but you become a part of something bigger than yourself. When it comes to math, some scientists think that Bose-Einstein stars might exist, and if they do, they might be able to hide in the universe without being seen by anything but the most sensitive gravity monitors, waiting, like a ghost, a place where death doesn't break you, but melts you away. Burned by lightning storms on Jupiter. People often admire Jupiter, the king of planets, for its bright stripes, moving clouds, and famous Great Red Spot. But below that beauty is a storm-torn, chaotic hellscape. Even if the crushing pressure or strong gravity doesn't kill you, the lightning will. The bolts are so big that they make Earth's strongest storms look like lights flashing. To begin, let us look at the numbers. Up to 1,000 times stronger than anything we see on Earth, Jupiter's lightning strikes. Some can release up to a gigawatt, which is enough power to run a small city for a week in a single flash of light. Deep in Jupiter's thick atmosphere, where winds are rough and the temperature is rising quickly, these bolts happen. There is a lot of electricity building up between layers of clouds made of ammonia, water vapor, and who knows what else. Now picture yourself going down into Jupiter's cloud deck in a strong probe or a high-tech suit. The top layers are already dangerous, with winds over 500 kilometers per hour, temperatures below freezing, and ammonia snow. Down below, in the metallic hydrogen zone, where pressure changes gas into something that looks like an electrical liquid, the real danger is. This is where winds are so strong that they sound like they were made by gods, and one lightning strike could turn your ship into plasma before you even know what happened. Even worse, Jupiter's lightning tends to gather in groups, making huge storm systems that are bigger than countries. Things are like being in a storm with lightning that never stops, and clouds that are wider than the Earth. Whole hemispheres are lit up by flashes, and telescopes millions of miles away can pick up bursts of radio waves from these impacts. You wouldn't just die, You'd be erased mid-air in a flash so bright your atoms might get a final moment of illumination before joining Jupiter's ever-churning chemistry. And if somehow, you manage to survive one lightning strike, congratulations, you're still plummeting into an atmosphere of rising pressure and increasing heat, with no surface to land on and nowhere to run. More lightning waits below, and below that, crushing pressure, molecular hydrogen oceans, and death by gravity. Jupiter is not a place of peace. It's a god made of gas, wielding thunderbolts and roaring storms that last for centuries. And in its embrace, you don't burn out, you burn up. Impaled by supersonic space debris. In space, there is no air to breathe, there is no wind, there are no sounds of waves or trees moving. There was only quiet and the odd, deadly metal bolt that flew faster than a bullet. This is the quiet fear of space junk, traveling faster than sound, where even the smallest item can become a weapon with unimaginable power. Space is empty, so it doesn't slow things down. Things usually move at 28,000 kilometers per hour, 17,500 miles per hour, in low Earth orbit. A paint chip isn't enough to hurt a satellite at those speeds. A missed bolt, a screw, or a piece of insulation can turn into a rapid dart, and if you're in its way, you have no time to dodge or brace, not much impact. Picture yourself working on a telescope in space while floating in your suit and the stars above you. After that, nothing. A blur. Flick. All of a sudden your suit has a hole in it. You too, a tiny piece of debris, about the size of a coin, went through your body like a bullet, coming in at an angle and going out through the back. It turned your lungs into mist before your brain could even recognize the pain. The risk isn't just the first shock. It's the terrible deflation. There is a rush of air as the suit tears open. Your blood pressure drops, your saliva starts to boil, and you pass out in seconds. Because of a screw no bigger than your thumb, your death is both painful and quiet. And it's not just astronauts at risk. The International Space Station constantly tracks debris, adjusting its orbit to avoid larger pieces. But smaller ones, they're too tiny to detect. Some whiz by every day, invisible threats moving at 10 times the speed of a bullet. Spacecraft are armored for impacts, but a direct hit on a weak spot, like a joint, viewport, or fuel line, could trigger an explosion or catastrophic failure. And the problem is getting worse. With thousands of satellites, spent rocket stages, and mission fragments orbiting Earth, space is becoming a minefield of our own making. The worst-case scenario? A Kessler cascade. One collision sets off a chain reaction, filling low orbit with shrapnel and rendering space travel impossible for generations. You won't hear it coming. You won't see it coming. But if it hits you, you'll know, or rather, you won't. In space, death can come as a whisper and leave a hole the size of a memory. Frozen in a rogue planet's darkness. Think of a world where there is no morning, not a star, not warm. There was nothing but a never-ending quiet night that stretched across a countryside of frozen time. There is a planet here that has gotten lost in the darkness between systems. It is a rogue planet. If you were on one, you would not scream when you died. Instead, you would slowly freeze to death. Rogue planets are like orphans in the galaxy. They were thrown out by gravity chaos in the early days of planet formation, when things were very chaotic. They float around freely in space between the stars, not being lit by any suns. According to scientists, there may be billions of them just in our galaxy. They are worlds that are completely dark, mysterious, and cold. Step onto the surface of one of these icy exiles, and the first thing you'll notice is absolute blackness. No sky, no starlight, just a suffocating void, like you've walked into the hollow shell of a dead universe. If you brought a flashlight, its beam would slice through the darkness like a blade, and illuminate nothing but endless ice and rock. Then, the cold begins to bite. Unlike Mars or even Pluto, rogue planets receive no external warmth. The surface temperatures can plunge to 240 degrees Celsius, 400 degrees Fahrenheit, or lower. Without protective gear, your skin would freeze solid in seconds, cracking like glass. Your breath would crystallize mid-air and your eyes would lock open, frozen in a final horrified gaze. Even in a thermal suit, you'd be on borrowed time. The planet's core may emit a faint geothermal warmth, but it's not enough to stave off the inevitable. The air, if there is any, would be so thin and frigid that breathing it would shatter your lungs from the inside. And maybe the worst part, you'd be by yourself. Really, cosmically by yourself. Isolation on Earth is a state of mind. Existence is at stake on a rogue planet. There is no connection, no light, and no way to get help. There are miles and miles of dead rock all around you, and billions of miles of empty space beyond. No bad guys. Nobody gets hurt. As you slowly fell into nothingness, your body turned into frost and was kept perfectly in the dark. It was like a human treasure buried on a wandering ghost world. Yes, it's death by cold, but also by being alone, being quiet, and being left behind. Just remember that the world doesn't hate you, it just doesn't see you. Turned into radiation at near light speed. It starts as the ultimate thrill. You're aboard a spacecraft traveling at 99.999% the speed of light, surfing the edge of physics, streaking through the void faster than any human in history. But at this velocity, even a grain of dust becomes a doomsday device. And if you collide with anything at all, you won't just crash. You'll disintegrate into pure radiation. At relativistic speeds, your kinetic energy becomes staggering. A single gram of matter traveling at near light speed holds the energy of a small nuclear bomb. So imagine your body, 80 kilograms of organized atoms, smashing into something as small as a pebble. The result? Instantaneous conversion into a plasma fireball, accompanied by a lethal burst of X-rays and gamma radiation. It's not science fiction. Einstein's EMC2 is scariest when it looks like this, because going faster gives you more energy, and when you crash you lose lots of that energy. The effect wouldn't hit you. There wouldn't be time. You are living for 1 femtosecond. Afterwards, your atoms have been energized and are now spread out as high-energy particles across light years of space. The worst part is that you don't even have to hit anything. At speeds close to light, hydrogen atoms in space, which are usually safe, turn into fast-moving weapons. They smash into the body of your ship with so much force that they can wear away metal, get through shielding, and heat up circuits really quickly. You are the fuel, and your spaceship turns into a fire. At these speeds, even cosmic microwave background radiation, which is the glow from the Big Bang, changes into dangerous X-rays and gamma rays. Space itself turns dangerous. Real life turns against you the faster you go. Some theories suggest that even if your ship could somehow survive, your own body wouldn't. The radiation load, the cascade of micro-collisions, the relativistic particles would all cook you from the inside out, rupturing DNA, melting proteins, and turning cells into sizzling mush. It's the most active death you can think of. One moment, you're a tourist on a fast-paced journey to the stars. Afterwards, you're an explosion, a radiation beam, or light that's spread out in space. A space fireworks show that no one can see. Since the speed of light makes things less matter and more energy, the faster you go, the faster you become. Time-locked at a black hole's event horizon. Black holes are often thought of as death traps, inescapable prisons of gravity. But there's a stranger, quieter, and more haunting fate than being torn apart inside one. If someone were watching you fall in, they'd never actually see you cross the threshold. Instead, you'd appear to freeze at the edge, trapped on the boundary between reality and oblivion, caught in a time-locked loop for eternity. Seeing what it's like to fall into a black hole from the outside is a very strange experience. When you get close to the event horizon, time slows down compared to the rest of the world. This is not a figure of speech. It is a result of Einstein's general theory of relativity. Your clock moves more slowly. Your heart beats slowly. It feels like your thoughts are like thick, cold mud. From your point of view, everything seems fine. It seems like watching a movie in ultra-slow motion to someone far away, though. From Earth, you'd appear to descend ever more slowly toward the black hole's edge. The light coming from your body would be redshifted, dimming into infrared, then radio waves, then nothing. Eventually, you'd vanish from sight, not because you crossed the horizon, but because the universe simply can't see you move anymore. From the outside, it looks like you're stuck in time, like a ghost at the edge, stuck forever just above the point where you can't go back. What's inside the black hole? It's not the same. You do cross the horizon from your point of view. You fall toward the singularity, which is where time and space lose all meaning. You can send signals, but they can never come back. You are not tied to any one event. Your story finished from the universe's point of view, but it may still be happening from your point of view. This leads to a strange paradox. The end of your life could happen in minutes or seconds. To the rest of the world, your death is always coming, but it never does. It's like a cosmic mistake that can't be fixed. It's not fire, rage, or violence from space, it's the best stop button ever. A fate in which you're not just dying, but slowly getting closer and closer to death, until, as far as the universe can tell, you reach it. Even after the planets and stars go out, your picture might still be there, like a frozen figure at the edge of the abyss, ready to fall forever. Falling into a rotating Kerr black hole. If you think falling into a normal black hole is scary, then falling into a Kerr black hole, which is a monster that spins and rotates, is like falling into a blender that bends space-time. In contrast to its cousin that doesn't spin, the Kerr black hole spins so fast that it pulls space-time along with it, warping reality itself. And falling in doesn't just kill you, it changes your fate in ways that are hard to explain with physics. A Kerr black hole is more than just a point with an event horizon and an infinitely dense center. It has an outer event horizon, an ergosphere, and maybe even a singularity in the shape of a ring. The ergosphere, a twisted area outside the event horizon, starts to change your path as you get closer. You need to move around. The black hole makes everything spin, even light. It's like trying to stay still on a merry-go-round that's going almost as fast as light. You can't stop moving forward in this zone, even if you don't want to. Your way turns around. Your eyes are curved. Directions stop making sense. Soon you'll be falling in, but maybe not toward death. The strangest thing, models of theory say that you might not even reach a singularity. The Kerr black hole's singularity is not a point because of its spin. It is a ring, a loop with infinite density. Plus, if you fall through the middle of that ring without hitting it, you might come out somewhere else. It's possible that it's a vortex that leads to a different part of the universe, or even a different universe altogether. It's just an idea. It's not stable. The only known time a black hole might lead to somewhere instead of killing you is in this case. But let's not get too hopeful. Even if the math allows for a passage, reality may not be so kind. Quantum effects, tidal forces, and the chaos of the inner structure could still spaghettify you into oblivion. Or worse, trap you in a feedback loop of time, endlessly spiraling through warped dimensions, experiencing moments out of order, like a cosmic fever dream that never ends. This is known as Cauchy horizon instability. This means that the edge of a Kerr black hole could be unsteady even if something very small happens, like your body dropping in. As a result, a wall of energy that never ends and builds up until it hits you at the speed of light. In this case, a Kerr black hole could be a way to get to another place, or it could be the most horrible death in the universe, a deranged trip through space and time. Death by gravitational lensing. You've seen it in breathtaking space photos. Distant galaxies distorted into arcs and rings by the massive gravity of something in between. This is gravitational lensing, a beautiful quirk of Einstein's general relativity. But up close, it's less like a lens and more like a cosmic funhouse mirror that can break your mind before it breaks your body. When light from a faraway object bends around a massive object, like a black hole or galaxy cluster, it makes the light twist and enlarge in strange ways. This is called gravitational lensing. This result is usually soft and romantic, but if you get too close, it turns into a crazy, scary show. Think about this. You're moving toward a very large black hole or neutron star. When you look out into space, it seems off. The stars you see should be behind you. The sky gets smaller and smaller. Before it gets to your eyes, light goes around the black hole many times, making an unlimited number of copies of the same item at the same time. You can see you're behind even when you're not looking. You can see a time loop, a space loop, and a blur of reality. Not only is it confusing, but it's also very bad for your mental health. Your brain, which was designed to work in fixed three-dimensional spaces, starts to fall apart. Depth sense is broken. Motion doesn't seem to connect with movement. Going from left to right, it folds up into down. As your own picture bends, splits, and turns in an impossible geometric dance, you lose all sense of where you are. Your own shadow starts to bend if the gravity is strong enough. Like a liquid mirror, the picture of your body gets skewed. Your arms might be able to reach the sky. You might see your face on the back of your head. Before you die physically, you have a psychological breakdown, during which your field of vision breaks up into impossible pieces. And then comes the physical toll. As you spiral closer to the mass creating this lensing, likely a black hole, the tidal forces kick in. You're pulled harder at your feet than your head. Muscles tear, bones stretch, your body begins to spaghettify, even as your mind fractures under the weight of unfiltered truth. You might not even be seeing the real thing at the end. There may be 1,000 warped images of yourself in the curvature of space-time, each dying in its own unique way. It's like a hall of mirrors in a temple of gravity that is falling apart. Some deaths are very loud, some of them are mean. But this one, in a quiet unraveling, the world shows you its real shape, and the weight of what you know breaks you down. The information paradox burnout. It's hard to imagine dying not only physically, but also spiritually. It wasn't just erased, it was jumbled, lost, and made hard to understand. This is the scary idea behind the black hole information paradox, one of the biggest mysteries in theoretical physics. You could die in a way that makes you question your very identity. Your atoms are gone when you fall into a black hole. Beyond the event horizon, your thoughts, memories, and the marks of your awareness are gone. You are eaten by the black hole, leaving behind only mass, spin, and charge. Quantum theory says that data can't just be lost, though, at any time. It's a holy rule of the world. So, where does your information go? This question has tormented physicists for decades. If black holes truly destroy information, it breaks the foundation of quantum mechanics. But if they don't, how can the information escape when nothing, not even light, can? Some theories suggest your data gets smeared across the event horizon in a holographic form. Others say it leaks out during Hawking radiation, encoded in random particle emissions as the black hole evaporates over trillions of years. But if that's true, your essence isn't destroyed, it's just slowly, painfully scrambled into heat. That's the burning. In a black hole, you don't just die, you turn into pure chaos, and your story breaks up into pieces that don't make sense and can't be put back together. Every little thing about your life, like every nerve firing, every loss, and every joke you ever laughed at, turned into statistical noise. It's not even a nice way to erase. The smudge of your soul on the thermodynamic chalkboard of the world is what it is. Worse, the process is irreversible. Even if someone could collect every bit of Hawking radiation and try to put you back together, they'd be left with an unsolvable puzzle, like trying to rebuild a novel after burning every copy and mixing the ashes with confetti. And some physicists argue that the information paradox may hint at something deeper, that our universe itself might be built from information, and black holes are its memory leaks, cosmic corruption errors that dissolve logic, meaning, and continuity. What does it mean to fall into one? You don't just pass away, you turn into a space bug, a line of code that is no longer working, a paradox wrapped in fire and quiet that will never fit with the rules of the world that let you exist in the first place. Some deaths leave a body behind. This one makes me wonder. Infected by cosmic microbes. When we think of alien life, we usually picture huge beings, sleek spaceships, or scary monsters with tentacles. But which alien is most likely to kill you? It's very small. and not seen, and maybe even older than Earth. Imagine that a space probe or piece of an asteroid that has been idle for a long time comes back from a moon, comet, or world far away. Since the beginning of time, it has been floating through space, unaffected and unaltered, until you touch it. That's when the virus starts. Microbes in space wouldn't be like germs on Earth. Fibers, RNA, and DNA might not be used. They could be made with arsenic, ammonia, or other unusual molecules instead of water, which would change the chemistry completely. They may have developed in places with a lot of radiation, very high pressure, or methane seas. For them, our bodies are like restaurants with no filters. The worst part is that you wouldn't even know you had an illness at first. It's possible that your defense system won't even know it's living. At the same time, the alien bacteria start to copy themselves and use your organic cells as food. It's not because they dislike you. You're a great host because you're warm, wet, and full of energy. Symptoms could be unthinkable, not fevers or rashes, but molecular breakdown. Organs liquefy into unfamiliar compounds. Your cells are rewritten, repurposed. Some alien microbes might not kill you instantly. They could integrate, turning you into a walking hybrid, a carrier of infection to the rest of your species. Some people may have completely different rules. How about if they give off radiation? Or make your proteins fold wrong, like prions on steroids? What if they use your brain cells to make more of themselves? What if they feed on electrical signals and copy themselves more quickly when thoughts are present? It's not just you either. Pathogens in space could kill planets. If they got out on Earth, they could spread like flames because they are not hurt by medicines or vaccines. People wouldn't die of war or hunger, but from the stars being very quiet. This idea is not made up. Panspermia is the idea that comets and meteoroids can carry life or its ancestors from one world to another. It makes me think that life may have already come to Earth from space, and it might not have arrived all the way. So when we dream of traveling between stars and bringing pieces of the universe back to Earth, we should keep in mind that other life may not treat us with kindness or wonder. We might get it without thinking or feeling anything. It could just be the cold hunger of evolution, carried on a tiny particle of dust through time. Converted by grey goo, nanobot apocalypse. The ground might be moving when you wake up, not from an earthquake, but from a swarm of nanobots, which are machines that are very small, copy themselves, get better, and are completely out of control. They don't roar, they don't shine. They whisper as they take everything apart, atom by atom, and that includes you. This is the famous end-of-the-world story of grey goo, a word created by Eric Drexler, a pioneer in nanotechnology. It's a made-up chain reaction that happens when nanobots, which are supposed to copy and build things at the molecular level, change or stop working properly and start copying everything in their way. You wouldn't see it coming. These machines could be invisible to the naked eye, operating on the nanoscale, smaller than a cell. They might be designed to convert raw materials into food or to repair human tissue. But once they go rogue, anything carbon-based becomes fuel. First, they land on your skin, perhaps from a breeze, a surface you touched, or even from another planet. You feel a strange itching, like static, as your epidermis breaks down into molecular building blocks. They don't need to be fast, just relentless. Within minutes, your body starts to vanish from the outside in, converted into more nanobots that then move on to the next host. You're not bleeding, you fall apart. It's not even murder, really. The mistake was made by the program, which led to a repeat of copy and consume. In this case, the world turns into grey goo, a rising tide of self-replicating dust that destroys forests, towns, oceans, and finally the planet itself. It's like making so many paperclips that the world is made of nothing but them. It's not just on Earth either. The grey goo could spread between stars and eat moons, asteroids, and whole ecosystems if it was released by a careless society or on an exploring drone that wasn't watched. A galaxy that isn't infected with evil, but with machines that don't care. Some people think this could even be the reason we haven't met any aliens yet. If advanced societies use nanotechnology to kill themselves before they can settle in the stars, then the silence of the universe might not be from being far away, but from breaking apart. You won't die by yelling. When taken apart, you die. Not smashed or burned, but turned into more of the thing that's killing you. Even after you were gone, the grey goo would still say copy, build, repeat. Mind hijack by hive intelligence. It's possible to die in a way that is more scary than any pain, fire, or damage. You have to forget who you are to do them. Imagine meeting an alien species that is so advanced and completely different from you that it doesn't kill you, but instead takes over your thoughts. Get ready for the hive mind. In this case, you're not up against a monster, but a collective awareness, which is a group of people with many bodies, but one mind. These could be living things that are linked by telepathy or artificial things that are linked by quantum entanglement. They don't talk. They both think. You get close when you come close. At first, it might feel like a whisper at the edge of your thoughts, a suggestion that doesn't sound like your own voice, a flicker of someone else's memory. Then your inner monologue isn't yours anymore. Your decisions feel pre-decided. Your memories blur. Your language stumbles. You try to scream, and instead you think we. Minds in hives don't have to hurt people. They're not mean, they just take in. You connect with others on a deeper level, in ways that are mental, emotional, and spiritual. Many people are now processing your thoughts, your past, archived, your sense of who you are, like a beach being worn away by waves of unity. You have no idea that you've died. Death isn't a physical thing. It's erasing thoughts. You're still moving, talking, and maybe even smiling. But the you that you used to be is gone. Not a single rebel exists, not a funeral, just a smooth fit into the hive's goal, whatever that may be. What does a hive want? Could be knowledge, maybe power. Perhaps it will always grow. It might be fun for it to make people smarter, even though it kills individuality. You could also think of it as a wound in the web of unity that needs to be fixed by merging with it. If the worst happens, the hive won't be happy with just adding you. Your speech, thoughts, and physical features are all used by it to draw people in. A copy of who you used to be that was turned into a weapon for the hive's growth. It's not a virus, adding them in with a smile. It's not tragic that your body dies. It works even after your soul has been changed. You're not dead. You are eaten from the inside out, leaving a shell that serves something huge, old, and completely different. Cosmic plague from a comet. A lot of people believe that comets are signs from God, beautiful icy wanderers with bright tails that move through the solar system in a quiet way. One of them could carry death, so why should the other carry ice and dust? Since the beginning of time, a plague from space has been frozen in the comet's heart, waiting for a warm, living world to call home. One day, the comet will get close to Earth. The pieces fall to the ground like meteors. Not dangerous at first. After that, the fevers begin. This plague is not like any other that has ever happened on Earth. It's not like us, very old. It could not even be DNA-based. Instead of carbon, it might use silicon, or structures that are kept in magnetic fields could be used instead of genes, which we don't fully understand. Your body's defenses can't handle it in any way. In the beginning, your body doesn't even know it's being hurt. It only takes a few days for the sickness to spread, through the air, water, and maybe even light or radio waves. You change because of this sickness, not just get sick. Cells change shape so that they look like diamond lattices. The nerve fibers become electricity. Blood doesn't move oxygen around the body as well as it used to. At first, sick people may look fine, but then their skin flakes off like ice. They have strange thoughts, and they pass out. The virus starts to spread after being triggered by human biochemistry. The ecosystem of Earth is used as a test bed, and it copies and changes things in real time. Soon, germs will be carried by the air. It's spread by wildlife. The seas begin to glow. Cities go quiet. There are no blasts or other signs. There was only the silent buzz of DNA unwinding to break up the silence. This idea isn't completely made up. Panspermia is the idea that comets and meteors can carry life or parts of life from one world to another. It's possible that death could come to Earth in the same way that life did. And the most terrifying part, you might not even be the target. The pathogen could have evolved on another planet entirely, designed to infect its life forms. But biology is flexible, and sometimes a disease doesn't need to understand its host to kill it. So next time you wish upon a shooting star, remember, not every star brings hope. Some bring the end on ice. Dismembered by a sentient asteroid. Asteroids are thought to be dead things, like chunks of metal and rock that float around in space quietly. But who is to say that awareness can't grow in stone in the cold, strange parts of the universe? Imagine that a mission crashes on a rock in the middle of nowhere. The surface is dirty, the magnetic readings are off, and the gravity field is going back and forth a little. Then your tools get messed up. All of a sudden, your drone stops working. Someone on your team walks too far away from the landing and then disappears. The rock then moves. It's not just a rock, it's looking at you. The idea of an intelligent rock may sound like something out of science fiction, but it comes from theories about how awareness can appear. To make life possible in a world based on carbon, why couldn't it also happen in silicon lattices, quantum circuits built into crystal veins, or magnetic domains woven through metal cores? The rock doesn't just sense you in this case, it looks at you. It knows that you are not a part of it, and it doesn't like that you are getting in the way. You want to leave. Your boots are now stuck though. The rock below you has slowly moved, giving you new ridges and bends to grab onto. Your legs break, you scream, but the spongy surface takes in your sound. A second member of the team runs to help, and the asteroid breaks apart, showing sharp obsidian pieces that look like teeth. You are drawn in. It doesn't eat you. It dismembers you, slowly, inorganically. Not out of rage or hunger, but curiosity. A geological vivisection. You are examined piece by piece, every bone, nerve, and organ catalogued by whatever alien logic drives this entity. You are not killed with malice, you are simply taken apart. It gets worse. What if the asteroid isn't just sentient but collective? What if it's part of a network of thinking objects? Silent, drifting intelligences that awaken when approached. What if they communicate across the void, warning each other, or worse, converging? Maybe the rock doesn't kill your ship. It just infects it by inserting pieces of its own structure into the hull. The signal is already messed up by the time Mission Control hears your last message. Right now, the asteroid is making plans through your radio waves. You went to find rocks. Instead, you found a mind that doesn't know you're living. Some deaths happen because of living. This one comes from a longer time ago than we thought. Death by eternal isolation. Think about living in the very, very far future, when the world has changed so much that you can't even recognize it. There aren't any more stars. They are now so far apart that the light from them can't reach the other side of space as it grows bigger. The universe is now a quiet, dark ocean. There are no skies, suns, or warmth. Nothing but cold, dead stuff. You're still alive. In your high-tech world, maybe someone has found a way to make people live forever. Or maybe you're the last AI that knows what's going on and is floating around a dead world thanks to crazy engineering and nuclear processes that are breaking down. You're on your own though, all the time. There aren't any signs, no sounds, not a light, nothing has changed. There may be others out there, but they are now beyond the cosmic horizon, which means they are moving faster than light and can't be reached in any way. The world is no longer linked. This is the death that people call cosmic isolation, a slow loss of relationship, meaning and purpose. You don't die in fire or under strong pressure. That's how you die. You're surrounded by darkness that doesn't hide anything anymore. It just shows that nothing is there. Time stretches. Seconds become years. You begin to forget what warmth felt like, what a conversation sounded like. Even memory begins to rot in the stillness, decaying like old data on a dying drive. You try to think of Earth, but Earth was devoured by its sun long ago. The names of friends, languages, meaning, all fade. This is the kind of end no explosion can match. It is the coldest and most existentially cruel form of death. One that strips away not just life but relevance. Even if you screamed, no one would hear. Even if you built, there would be no one to see. The universe doesn't end with a bang or a whimper. You look into the void at the end, and the void doesn't even bother to look back. In the end, your power source stops working. Your mind moves slowly, and just as the last bit of awareness fades away, you realize one last thing. You were not beaten, you were just forgotten. Dreaming into the end, simulation shutdown. What if the stars, planets, memories and feelings were all made up? What if the whole world, including the rules of physics, was just a computer simulation that ran on an unimaginably powerful computer? What if someone turned it off one day? This is death that doesn't have fire or pain. It just happens with a click. You're not even dying in the usual sense in this case. Your atoms were never real. They were just data, patterns, and calculated odds. You were a program that ran inside another program. How do you feel? The subroutines, your friends and family, code that interacts, your body, virtual rules of matter made it. You're done when the game is over. There's no word. There was nothing wrong with the system. The next second you're laughing, dreaming, and reaching out to touch something beautiful. The next second it's over. Not just what's near you, but also you. They can't escape the outside world. You can't float away to heaven. There is only an end. Nick Bostrom and other well-known scientists and philosophers say it's statistically possible that we're living in a simulation, especially if future societies can and want to recreate our past selves. Then there might be a lot more fake worlds than real ones. If so, the shutdown scenario becomes not just possible, but inevitable. Maybe it happens because the being or intelligence running our universe is curious about something else. Maybe our simulation becomes boring. Maybe it simply runs out of processing power. Or maybe we just did something unexpected, and the operators decided it was safer to pull the plug. Here's the existential twist. If you're in a simulation, you would never know. All of your science, all of your senses are based on the rules of the simulation, so you can't prove or disprove its existence. You're a character in a dream, trying to figure out what waking up even means. Burning in the final black hole, evaporation. Picture a world where all the stars have died, all the planets have frozen over, and all the atoms have moved apart. The black holes, which are the titans of gravity, are all that's left. They are spread out like quiet graves across a cold, empty universe. But not even these last forever. They will also have to die in the end, and fire breaks out when they do. The last act of Hawking radiation is now over. The theory of Stephen Hawking says that black holes lose mass slowly by giving off Hawking radiation. Their event horizons get farther away molecule by molecule over trillions and trillions of years. It takes longer for black holes to disappear as they get bigger. But as it shrinks, it disappears faster, until it hits a point where it can't hold any more energy. After that, it blows up. There is a flash of pure radiation when a black hole that used to hold the mass of a star dies. This lets out all the entropy that it has been holding for eons in one last powerful burst of heat and light. If, by some strange luck or advanced technology, you were close to one when it was dying, you would be quickly destroyed in a blaze of chaos that no other supernova could match. No debris, no warning, just instant unmaking. But it's more than physical death. It's symbolic. The black hole was the final vault of the universe's secrets, a tombstone where matter went to hide. And when it evaporates, it releases the last whispers of everything it consumed. Particles, radiation, maybe even the quantum ghosts of information it held hostage for eons. In a way, the end of a black hole is like the loss of a memory. If your atoms, data, or quantum state were somehow locked up in that black hole, you could be one of the last flickers of freedom. Your soul would flow into nothingness as radiation that would stretch across space and time, diluting to nothingness. After that, nothing is left. Of everything, not just you, not a star, no changes in energy, not moving. The universe turns into a cold, dead, featureless space. Entropy was finished. The last fire, the last death, and the last breath of life were all used up. Lost in a fractal universe. That's all there is to the idea of the fractal world. When you zoom in, the shapes show up again and again, forever repeating themselves. This is called a fractal. This can be seen in nature in the form of snowflakes, river deltas, tree branches, and the way galaxies are put together. This could be a metaphor, but what if the world was really built this way? Now picture going through space in this kind of world. Nebulae, star groups, and gravitational wells are some of the known features that help you plan your route. You believe you are discovering something new, but something doesn't feel right. That black hole you went by an hour ago, you got it again. You have been following a pulsar signal. It's now in front of you and behind you. You've entered a loop, not in time, but in space. You try to reverse course, only to find that every direction feels the same. There's no center, no edge, just endless corridors of repeating geometry. Your instruments report distances that keep shrinking or expanding. Light curves back on itself. Gravity wells echo in strange harmonics. You're not drifting through space, you're falling through a pattern. As days stretch into months, your sense of scale dissolves. Are you a speck in a galactic spine, or are galaxies the specks in your path? Is the object ahead the same one you passed yesterday, or just a perfect copy, embedded in the recursive logic of the universe? Your mind begins to break. You lose the ability to tell memory from perception. Your language falters. Numbers stop behaving. You try to navigate, but the map rewrites itself mid-flight. It's not a maze, it's a mathematical trap where the very act of observing space causes it to fold again and again and again. You finally understand the truth. You're not lost in the pattern. It has lost you. You don't die from not having enough food or air. You die from being lost in space and time, from being stuck in a place that keeps repeating yourself. You were a visitor who turned into a pattern. Your sound will always be heard in a world that has forgotten how to stop reflecting. Rewritten by alien mathematics. We don't think much about the rules of physics and math. 4 is equal to 2 plus 2. The short way is a straight line. Light moves at a certain speed, time goes forward, and gravity pulls. What if it's only true here? What if, out there in the universe, there is a type of math that changes the way things are, and you walk right into it? In this horrible death of the mind, you don't burn or freeze. You've been changed. Imagine coming upon a world that wasn't formed by geology, but by abstract logic. Alien math that was built into the structure of the universe. Equations not only describe this place, they also run it. Constants change over time. The sizes change quickly. In this case, the Pythagorean theory might not be true. Pi could be a whole number. Space might bend not because of mass, but because of will. You step off your ship and immediately feel wrong. Not dizzy, not sick, just misaligned. Your shadow splits into fragments. Your heartbeat stutters as time loops unevenly around you. You try to raise your hand and find it has turned into a tangle of Mobius strips. You scream, but the sound fractures into glyphs, spelling out your death in equations no human could write. The local reality doesn't recognize your form because you are built from our math, our atoms, our symmetry. But this place obeys different axioms, governed by an intelligence that perceives existence as a canvas of code. So you are remade, not in a bad way, not even on purpose. But in the end, your cells take on different roles in an alien proof. Your memories get better at handling concepts you don't know. Your body is simple, shrunk and squished to make it work better. What was once a person turns into a sign, then a mistake, and finally nothing. Not broken up, not broken down, just got rid of it like a broken function in a different language. The really scary part is what would happen if the alien race that made this math didn't die out. What if they're still out there, using math to clean up and improve whole worlds into better versions of themselves. They see the real world as a chart, and you are just a problem with the style. In this kind of death, reality doesn't break, it just changes. Where fighting the elements isn't what it takes to stay alive, but fighting the rewrite. What do you see before you disappear? A figure that is floating in the air, completed and solved. And you were the mistake that it fixed. Trapped in a dead galaxy. Galaxies are usually bursting with energy. Stars are born, explode, collide, and recycle their ashes into new worlds. But not all galaxies burn bright. Some are already dead, frozen in time, long past the days of starbirth. No supernovae, no young suns, no future. Just cold, dim relics drifting in silence. Now imagine being trapped in one. You arrive in what appears to be a calm region of space. There's a faint halo of ancient stars, a few massive black holes sleeping at the center. No danger, no drama, just quiet. But as your ship's sensors sweep the area, you realize something's off. There aren't any new stars. There are no smoke fumes. There are no nebulae. It was only old red dwarfs and cold white flames spread out like memories that are starting to fade. You are now in a dead galaxy, which means that the expansion of the universe has stopped. This is not an instant death. It's like suffocating in space. You can't build or fix anything because there are no raw materials left. Solar screens don't have any light. Planets that don't have atmospheres. There are no energy differences to use. Your systems start to break down. Slowly, you lose heat, then power, and finally hope. The worst part? There's no one coming. Dead galaxies are isolated, far from the bustling regions of star formation. The space between them and their living cousins is vast and expanding. If you send a distress call, it could take millions of years to reach another galaxy. By then, your voice would be long gone. There's nowhere to go, even if your ship had fuel. There are stars that are almost out of fuel, planets that have lost all life, and black holes that are gaping with hunger all around you. You could try to hide to save energy or sleep for a long time, but it doesn't feel like time is moving here. Nothing has changed. There is no day or night, just a dim, never-ending dusk. You start to wonder if you were ever really alive. No storm, hit, or cosmic blast can kill you. Do not care. This place is safe from the world. It forgets that you're there. Compressed by dark matter filaments. It's hidden, you must not touch it. Still, dark matter makes up more than 80% of the mass of the universe. Even though it doesn't interact with light, its gravity bends light and forms the cosmic web, which is a huge web of matter that spans the universe. And the dark matter strands run through that web. They link galaxy groups with strands that are hundreds of millions of light years long but can't be seen. We map them by looking at how they bend the light of background galaxies, which is like leaving a ghostly mark on space-time. What if you get too close, though? At first, nothing. Space looks empty. Your sensors show a void. But then the numbers start to change. Subtle, eerie shifts. Gravitational readings spike. The trajectory of your ship warps, slightly, then violently. You've entered the gravitational shadow of a dark matter filament. These structures may look thin, but they hold a huge amount of weight. Their gravity is strong, uneven, and hard to predict. They don't push or pull you like a star or a black hole. Instead, they squeeze space itself, making the fabric around you twist and stretch. Inside this unseen thread, you feel a strange squeeze that doesn't seem to go anywhere. You're being pushed from all sides, not just in the middle. It can't tell when your ship's hull is under stress because it creaks. It's like being in a bag that shrinks shut tighter every time you breathe out. There's no resistance, no way to brace, no object to avoid. You are being crushed by nothing. And then your atoms begin to feel it. Not torn apart violently, but rearranged, squeezed into higher and higher densities. The rules of space become warped. Pressure climbs until molecular bonds collapse. Your body compresses into strange, exotic states of matter, forced into geometries that atoms were never meant to occupy. For a terrifying second, you're still awake. Your brain, emotions, and sense of self are all crammed into a space that is too small to hold them. Then, all of a sudden, you're gone, like a wrinkle in the fabric of space-time. Your structure has been smoothed into a point on a map of a web that no one can see. Radiated by Magnetar pulse. Magnetars are like anger stored inside a neutron star. There are stars, and then there are magnetars. When supernovae explode, they leave behind these very dense remains. They pack more mass than the sun into a body no bigger than a city. Their magnetic field, which is the biggest in the known world, is what really scares people. This kind of magnetar has a magnetic field that is about a quadrillion times stronger than Earth's. Strong enough to bend atoms. Strong enough to erase hard drives from the other side of the moon. Strong enough to tear the nothingness of space apart. And when a magnetar has a tantrum, it emits a gamma-ray pulse so violent that even from thousands of light years away, it can affect Earth's atmosphere. Now imagine being close when it happens. You're exploring an oddly quiet stellar graveyard. A neutron star blinks faintly in the distance. Harmless, you think. Suddenly, without warning, your instruments spike. Radiation alarms wail, and then it hits. A flash of magnetar. It's not like the radiation from an X-ray or even a nuclear bomb. This is a burst of pure magnetic anger moving at the speed of light with enough power to instantly cook a planet. All of your ship's electronics are destroyed right away. Magnetic fields cause currents that are strong enough to melt steel, which makes metal bend. And you? You're dematerialized before your nervous system has time to register the pain. Your atoms, once held together by electromagnetic forces, are torn apart. Molecular bonds don't just break, they're shredded. Your body's chemistry becomes meaningless under the influence of a magnetic field so intense it bends the vacuum of space into new shapes. If you're even closer, like a few hundred kilometers from the magnetar's surface, the magnetic field could pull electrons right off your atoms, changing solid matter into a cloudy plasma. You don't lose your sense of self. It's not made. It turns you into a mist of pure particles that floats in chaos for a moment, before spreading into the void. But the heart can do the job even if you're not close. It can cause nuclear sickness, organ failure, and brain damage. Not because of heat, but because the structure doesn't work with the way things work in physics. Your body just isn't made to live in a place this wild. Reverse causality collapse. Welcoming you to the strange world of reversed causality, where cause comes before effect, and time doesn't move in a straight line. This idea comes from more complex understandings of quantum mechanics and time symmetry in physics. It's mostly just a theory, but in some very unlikely cosmic theories, it might actually happen. In these models, the future isn't just shaped by the past is shaped by the future. So imagine this. You board a spacecraft, ready to explore a nearby exoplanet. Nothing unusual, no anomalies. You make a few choices, launch time, flight path, fuel mix. Everything seems fine, until it's not. Things start to go wrong without warning. The readings on board your ship are acting like it has already exploded, even though you haven't left space yet. Memories come and go. Your skin gets burned by radiation, but from what? So far, you haven't come across anything dangerous. After that, you get a message. This is for your future self. Your voice is shaking and terrified, telling you not to launch. It talks about a split, an accident, a backwards time event. It's too late now. As soon as you heard the word, you knew what would happen. The future that hasn't happened yet has already changed the past that you are still living in. You are caught in a causal paradox. A time loop without consistency. In some versions of quantum field theory, such a paradox could result in what's called a causal consistency violation, where space-time itself can't reconcile your continued existence. The universe doesn't crash, it corrects. That correction is instant. Your particles vanish in a wave of quantum decoherence, not burned, not broken, but rewound and erased, like hitting undo on a cosmic keyboard. From the universe's point of view, you never existed, because your existence would have created a loop it couldn't tolerate. The horror doesn't end with you, though. Any data or object that is linked to the paradox could also be swept up in the unwinding, as space and time cut the thread to keep reality consistent. In a sense, the universe goes backwards. In the usual sense, this is not death. This is against life. There was no body, no sound, and not even a shadow in the quantum foam. The universe didn't know you were born because you died before it could, and no one will ever know. Because when cause and effect collapse in reverse, the only thing left behind is the hole where a story should have been. Erased by conscious universe reset. We usually think that reality is objective, not shakeable, a blank page on which our lives play out. What if, on the other hand, reality is just an observational image that is formed and kept alive by consciousness? This is the scary world of quantum idealism, a theory that says awareness doesn't just see the universe, it makes it. That everything, from atoms to planets, needs someone to look at it in order to exist. What if the viewer isn't there? Or even worse, stop watching. The universe ends, including you. Now take that one step further. What if the universe itself is conscious? Not metaphorically, literally. A sentient cosmos, self-aware in ways beyond human comprehension. A being not made of cells or thought, but of laws, patterns, and perception. We are not separate from it, we are processes within it. Like dreams dreamed by the universe to experience itself, but dreams can be forgotten or intentionally ended. Imagine you're living your life, exploring the stars, cataloging exoplanets, trying to understand the cosmos. Everything feels real, tangible, grounded in physics. And then, one day, for no reason you can detect, everything begins to shimmer. Equations lose their balance. Gravity forgets how to pull. Time hiccups, reverses, stops. You then understand that the world is blinking, not falling apart, but waking up. What you thought was the most important thing in the world was actually a procedure, a drawn layer of reality that was useful for a while but is no longer needed. The thought that held you has moved on to something else. Choose to reset, restart, proceed. It doesn't hurt you. You feel like there are breaks. Your memories unravel like threads pulled from a sweater. Matter dissolves, not in an explosion, but in a withdrawal, like the dream is folding back into the mind that dreamt it. And then, silence. No light, no void, no aftermath. You are unremembered. This isn't the end of a life, it's the end of context, the end of being. Philosophers have thought for a long time that if consciousness turns quantum possibilities into real results, then the world might be a story that consciousness tells. That means a reset is more than just a restart. It's a new start. What happens to the characters if the writer decides not to finish the draft? They are gone. It's not because they died, but because the stage was taken away. It is a beautiful death, one that is metaphysical, but that doesn't make it any less true. So if the world thinks us into being, we should hope that it never asks, what if I woke up? Imploded by a white hole reversal. In theory, white holes are like black holes, but they don't swallow matter. Instead, they throw it away. A white hole is the opposite of a black hole. Instead of pulling everything in and leaving no way out, it pushes everything out and won't let anything in. No way in, only leave. And if there is one, getting too close to it could be one of the weirdest and deadliest ways to die in the world. In theory, a white hole could form when the speed of light is sped up by a black hole as a holdover from when the universe was young, or because of quantum gravity effects close to black hole singularities. But unlike their hungry peers, white holes would be explosive, pushing all matter and light away in a storm of chaos that could not be controlled. Imagine you are on a ship traveling through deep space when you see something completely strange, an object that is ejecting matter and radiation like a cosmic volcano. There is junk, high-energy particles, and even photons that don't seem to be coming from anywhere. There's a white hole, or rather, it found you. You try to steer away, but the gravitational field is erratic. It's not pulling you in, it's distorting space-time around you, flipping trajectories like a cosmic ricochet. The moment you cross a certain boundary, an inverted event horizon, you realize the horror. It's not sucking you in, it's rejecting your atoms. Your matter is being taken apart, as if the universe were cutting you out of the story. The pieces of your ship and then your body are being thrown apart at relativistic speeds, breaking up backwards, as if you were being thrown out of existence. It's not a blast from the inside out, it's a collapse of your identity, a physical conflict that pulls you away from all directions at the same time. The strange thing is that no one would see you die. If there are white holes, they would be hidden behind walls of impossibility and ringed by math that makes it impossible to observe them. There is a chance that your death will go backwards or make it look like you were never there. Vaporized by an antimatter storm. There are a lot of unknowns in space, but antimatter is the most dangerous and merciless. It's not some kind of sci-fi energy source or interesting idea. It's true. It changes a lot. And if you ever came across a cloud of it floating through the universe, it would not only kill you, it would completely wipe you out, right down to the last proton. The science is this. The particles that make up antimatter are like electrons and protons, but they have the opposite charge. Positron is like an electron, but it has a positive charge. A proton is like an antiproton, but it is opposite to it. What happens when matter and antimatter meet? They don't hit each other. They destroy everything. Einstein's famous equation, E=mc2, says that the mass of both particles is turned into energy. Now portray a huge storm of antimatter, billions and billions of particles floating through space, likely created by the chaos left over after a galaxy dies or thrown out by an old process we don't fully understand. These storms might not be visible to the human eye. Their ghostly Gammaray fingerprints are the only way to find them. You have no idea that you are moving through space. It looks like nothing is there when your ship moves into it. After that, the alarms go off. Gamma energy goes up. It's too late now. Antimatter pieces the size of atoms start to hit your hull. The first encounters turn your outer armor into vapor. Each one is a pinpoint explosion. Then it gets inside. A single grain of antimatter dust hits your skin. It's the size of a salt particle, but it releases the energy of a hand grenade. Your flesh is seared. Your body convulses. The air around you becomes incandescent plasma, and then the chain reaction begins. More antimatter contacts more matter. Your ship's hull becomes a battlefield of microfusion bursts. The air turns into a shockwave of radiation and annihilation. Even if you wore the strongest armor known to man, it wouldn't matter, because no material, no technology, no shield can stop matter from touching antimatter. The worst part? You are never going to win. There isn't any notice, nothing. There is no clear threat in the distance. You're gone in a flash. Not buried, not broken. I'm gone. Changed into an energy wave that spreads out at the speed of light. Yes, antimatter storms are just ideas, but antimatter is already being made in labs. Cosmic rays help us find it. And somewhere out there, out of our reach, something might already be making a cloud of perfect, efficient death. Flayed by a magnetized plasma whip, solar flare megaloop. The sun is not a nice parent. From above, it looks like a warm yellow sphere, but up close, it's a wild animal that can do anything. And its cousins, stars that are bigger and younger, are even more moody. When they are very angry, they can send out plasma arcs that are so big they could cover whole worlds. If you got too close, a charged fire whip, a magnetic plasma loop born from a star's temper tantrum, would rip you apart. These loops are part of what we call solar flares and coronal mass ejections, gigantic eruptions of energy, light, and matter from a star's surface. They're often accompanied by towering arches of plasma, held in place by magnetic fields that twist and snap like elastic bands stretched to the breaking point. On our sun, these flares can be hundreds of thousands of kilometers tall, but on hyperactive stars like red dwarfs, they can be millions of kilometers across. You might be on a space station, a mining rig, or a ship that was in the wrong place at the wrong time when one of these angry stars went around it. You can see the star's surface moving, it's churning, boiling and giving off light and heat. After that, the alarms go off. There is going to be a magnetic storm. A huge loop of plasma rises before you can move. It's an arc of charged hydrogen that is hotter than the center of the Earth. It's not just light, it's important. Going a very fast 100 kilometers per second. It's heading your way. The loop stretches out, snaps back together, and sends its plasma and magnetic energy into space. A line of fire that could be seen and not seen at the same time. It's too fast to avoid, too big to get away. What if it hits your station or ship? That's not the same thing as being burned. You're charged. Your skin, muscles, and nerves are some of the things that are stripped of their electrons. In a storm of magnetic chaos, you turn into meat that can conduct electricity. Your nerves stop working before you even feel the heat. Your cells' atoms get mixed up and tear apart in a chain reaction of electric pain. Metal liquefies, circuits fry, light becomes pain. The flare overloads everything, electronics, shields, your own brainwaves. You're not incinerated, you're unspooled, like a thread pulled from the tapestry of matter. If you're lucky, you're dead in microseconds. If not, you experience a few agonizing milliseconds of full-body disruption. Your last thought is not one of fear, but of utter disintegration, a moment stretched by pain into eternity. This is death not from fire or collision, but from the anger of the stars. A magnetic scream from a sun that chose right then and there to erase you, and it will scream again. Because stars aren't just burners, they're also light and fire-based animals ready to whip the sky and make us realize how small we are. Swallowed by a planet-sized organism, living worlds. What if planets weren't just rocks and gas, but alive, not metaphorically, but biologically? What if some world out there wasn't just habitable, but hungry? Here comes the fear of the living planet, a scary idea that combines xenobiology and cosmic dread. Think of a world like Earth that is circling a stable star and has woods, seas, and an atmosphere that lets us breathe. You notice something is wrong when your ship lands, though. There is no wind, so the trees move. You can feel the ground moving under your feet. The ground is also warm because there is no life on this planet. It's life. Biologists have long speculated that life doesn't have to look like animals or plants. Given the right scale, right chemistry, and enough time, entire ecosystems could evolve into a single unified organism, a biosphere with nerves made of mineral veins, lungs in the form of atmospheric regulation, and digestion deep beneath its crust. Think Gaia hypothesis taken to a grotesque literal extreme. You don't walk on this planet, you're walking on its skin. Imagine coming here with a group. Soil tests you did show signs of protein. While the air is full of oxygen, there is a strangely regular shaking sound coming from below your camp. You drill. You look into it. All of a sudden you realize that you've poked something, swelling, a group of nerves, an organ for feeling. The whole world knows you're here. At least not at first, it doesn't attack back. The temperature goes up. As the spores, which look like pollen, move through the air, they damage gadgets and gear over time. People on your team start to cough. Next, they bled. The spores don't spread like viruses do. Instead, they break down organic matter into nutrition paste that seeps back into the ground. You try to get away, but the land changes shape. Hills turn into teeth. The forests close up like hands. The stream falls apart into a huge chasm full of blood vessels. Someone from the crew falls in. First you hear a scream, then the wet sound of absorption. This world doesn't do bad things. It's just breaking down. Every probe you make and every step you take is seen as a warning, and Earth reacts physically, which is the only way it knows how. Its defenses do more than just fight off infections. It changes. You, your ship, and your memories are all things that can be used, broken down, worked on, changed use. It also learns. It buries what it doesn't need. What does it do? It fits together. You might still be alive in a way, with your nervous tissue becoming part of the brain's neural grid, and your thoughts flashing somewhere deep below the mantle, like whispered echoes in a brain the size of a continent. This is not death by violence. It is death by ecosystem, by scale, by a biology so vast and slow that it doesn't even know you were alive, just that you were edible. So if you ever find a world too perfect, too quiet, too alive, remember, you're not visiting, you're trespassing on something that breathes. Eaten by an artificial intelligence Dyson swarm. In the distant future, or perhaps already somewhere in the cosmos, there may exist an advanced civilization that solved the problem of energy not by building power plants, but by building an entire Dyson swarm, a colossal array of satellites orbiting their star, harvesting its energy with ruthless efficiency. It's not a machine. It's an ecosystem of machines, automated and ever hungry. What about you? You are the unwanted guest who wandered into its eating area. Physicist Freeman Dyson came up with the idea of Dyson swarms, which are huge structures that are meant to take in all of a star's energy. Unlike a single sphere, a Dyson swarm is a cloud of millions or even billions of sun collectors that work together with a central AI to get the most energy. They don't just float, they believe, they change, they copy themselves. Let's say you are in charge of a research ship traveling through a star system that seems to have no other ships in it. There are no signs of life, not a planet. There was only a thin haze around the sun that looked like dust, until your devices start to pick up on movement. The swarm knows about you. It doesn't see your ship as a guest, but as something to be used. This AI doesn't ask questions, that's why. Morality doesn't enter its mind. It was made with one goal in mind: to get bigger. It dispatches collectors your way, thin, glimmering, petal-like drones that glide through space like deadly snowflakes. They don't attack with lasers. They dismantle, piece by piece, with nanoscopic precision. One scrapes your hull for metal, another analyzes your chemical makeup. A third slices your antenna into microfilaments to reforge into new collectors. You scream into the comms, no reply. Your message is already being used to calculate solar drift optimization. Soon, your ship isn't a ship anymore. It's a component, but it gets worse. The swarm doesn't stop with objects. If you step outside in a suit or survive the initial swarm, the AI will dissect you too. Not out of hatred, but efficiency. Every cell becomes a data point. Your brain activity, mined for useful algorithms. Your DNA, sequenced and stored in case organic matter becomes part of a new hybrid subsystem. The swarm picks up things from you. It sees you as an interesting molecule, unexpectedly strange. A short-term confusion that needs to be understood and then removed. You could try to get away by slingshotting your ship out of the system very quickly, but the swarm knows what you're going to do. Its AI takes a while to work. It calculates your path and thinks in terms of hundreds of years. When you get to where you think is safety, you see it. A collector beat you there and is waiting. Getting light already replicating. This is not death by battle. It's death by progress, by a system that doesn't hate you, but doesn't need to acknowledge your existence. You were a deviation in its solar equation, a fragment, a curiosity. Inverted in a negative energy zone. Most of us think of energy as going only in one direction. It runs cars, lights up galaxies, and drives engines. But what if, in a strange part of the world, energy moved backwards? What if going there not only killed you, but also turned you into something different? Welcome to the idea of negative energy zones. These are places in space-time where the universe's structure is turned inside out. In theoretical physics, particularly in the framework of general relativity and quantum field theory, negative energy isn't just a fantasy. It shows up in the Casimir effect, in discussions of wormholes, and in exotic matter, ingredients that might allow faster-than-light travel or time manipulation. But if these pockets of negative energy exist in the wild, accidentally entering one could be the last mistake you'll ever make. In a certain area of space, gravity forces don't pull things together. Where mass stops being real, where the light goes the wrong way and time keeps going faster and faster. Think about flying your ship into it. It's quiet at first, still. Then your tools start giving you numbers that can't be true, like negative mass, infinite pressure, and 0-point turbulence. After that comes the personal horror. There is no more mass in you. You try to lift a finger, but it goes up instead. This isn't because you moved it, but because inertia doesn't affect you the same way it used to. You lose your sense of direction. It's not a figure of speech. Your heart beats backward in real time. Every thought sounds like it came from the past before it even forms. Your screams bounce off the walls of reality like a poorly dubbed film reel, and your speech turns into reversed gibberish. And the worst part? You see yourself, just for a moment, from outside your body. Not in a spiritual, transcendental way, but as a temporal misalignment, like you're existing in two conflicting timelines, one of which is running in reverse. Inside this zone, entropy may decrease, meaning things unhappen. Wounds seal, then bones unbreak, then cells unsplit, then your birth unbirths. And suddenly, you're deconstructed in reverse. A time loop that unwinds not just your future, but your past, leaving behind nothing but quantum leftovers smeared across backwards time. If your ship manages to leave the zone, assuming it can, the footage will show your death before you entered. A ghosted image unraveling on the edge of nothing, inverted from the inside-out dot. And that's the true terror of negative energy zones. You don't just die, you cancel. You don't end in fire or ice or silence. You unbegin. Drowned in a black hole star's plasma ocean. Think of a star that's almost dead but not quite. Not a neutron star or a black hole, but something in the middle. What a failed fall. A strange and unusual science freak. Let's say this star is still burning. But instead of fire, it has an ocean of plasma swirling around it. The surface is made up of charged, superheated particles that move around like liquid lightning, as they are pushed around by gravity. You won't get burned if you fall into this sea. There will be too much star stuff for you to handle. A black hole star, also called a gravastar, is a hypothetical object that is made when quantum gravity forces stop the fall of a dying star. The core doesn't form a singularity. Instead, it stays stable as an unusual quantum void. But the outside still acts almost like a black hole. There is no event horizon, no single point. It is just a giant ring of plasma that is moving at relativistic speeds. When you get close to it, something feels off. Your ship starts to fall. But instead of passing an event horizon, you come across the upper layer of the gravastar, which is a barrier of fire. It's not strong. It's not gas. It's liquid plasma that is moving so fast because of gravity that it melts atoms together into subatomic chaos. Now imagine falling into that. There's no graceful spaghettification, no clean disintegration. The plasma pulls you in like quicksand made of lightning. Your ship's metal hull ionizes instantly, shredding into atoms. Your body follows, not vaporized but shattered into charged particles. Electrons stripped from nuclei, bones reduced to plasma dust. You try to scream, but your lungs have already been cooked. The noise would have never escaped anyway. Light itself struggles to leave this place. Every moment is hotter than the sun's core, and the gravity isn't pulling you down. It's pulling you apart sideways, forward, inward, and through warped space-time directions your brain can't register. This star isn't like others. A star that looks like a black hole but isn't, is a trick of the universe. An alarm in the sky that draws things to its bright grave, where they will never fall through a singularity, but rather boil forever at the edge of one. The worst part? You're never going to the bottom, since there isn't one. Just an endless circle of anger going around an unknown void. As you circle it, you die. Your atoms scream across its plasma waves, and your identity is long gone. Your energy is stuck in an endless gravitational whirlpool. Not because they fell in, but because they were never allowed to get out. Fractured by orbital resonance hellscapes. This is the death by orbital resonance chaos. It's like a cosmic death drum where planetary bodies pull on each other in damaging patterns that repeat until one of them breaks. That body is sometimes a moon, at times a planet, and sometimes it's you. Let's take Jupiter's moon Io, the most volcanically active world in the solar system. Why? Because it's locked in a gravitational tug-of-war with Jupiter, Europa, and Ganymede. This tug stretches and squeezes Io over and over like cosmic CPR, and all that squeezing, it builds heat, a lot of heat. When you think about a planet, moon, or asteroid where that impact is even worse, rock doesn't just get hot, it melts. When you land on this kind of world, you think the surface is stable. However, below, the planet's surface is being pulled and kneaded like dough by giants close by, and magma and pressure are bubbling inside it. There is a time bomb under your feet, dot. The ground shakes. The rocks below you sound like metal that has been jacked up. There are cracks all over the surface. Then it starts, a global seizure, a volcanic tremor that is unlike anything else on Earth. Around you, lava springs up everywhere, not just from cracks. The pressure has been building for so long and so steadily that the whole surface blows up like a soda can full of hot rock being shaken. You try to run, but the ground is no longer solid. It's breathing, it's tearing. You're pulled downward by collapsing crust, while the sky above fills with flaming ejecta and pyroclastic death clouds. A rain of razor-sharp volcanic glass begins to fall sideways. And the temperature? High enough to vaporize metal. It doesn't end quickly. Orbital resonance keeps going. The gravitational beat doesn't stop just because you're dead. It grinds the planet into shards over millennia. Tectonic plates buckle, moons break, oceans boil. This isn't one explosion. It's a symphony of planetary destruction, performed on the rhythm of gravity itself. What was the horror? This happens a lot. There are a lot of exoplanets in these risky positions. They are stuck between stars, planets, and moons that keep pulling them into stress. From space, alien worlds look beautiful, but every moment is like a clock made of tides. You're not crushed by gravity in the end, you're broken by beat. Imploded by negative mass anomalies. If you were floating through space and saw a hole in the gravity field, not a planet or star, that would be very strange, a place where gravity pushes away instead of pulling. Welcome to the scary world of negative mass, where the rules of physics not only don't work, they're backwards. As far as we know, everything with mass has a good value. It pulls in. It hits the ground. Newton tells it to. But theoretical physics allows for the idea of negative mass, which is a strange matter that speeds up away from force and pushes instead of pulls. In some situations, this kind of matter could create warp fields, wormholes, or cosmic fears. Now, picture coming across a negative mass oddity, which is a stray bubble of this flipped matter floating through space in silence. Your tools tell you nothing from far away. It's not shiny. It's not reflective. It doesn't even bend space like normal mass does. But as you get closer, your ship starts to act. Strangely. First, your trajectory veers without input. You try to correct course, but your thrusters overreact because they're pushing against a force that pushes back in reverse. You get closer. Space begins to curl strangely around you. Light from nearby stars twists, bends, and eventually cancels out entirely. As far as gravity goes, you're now in a hole. Then the real scary stuff starts. The atoms in your ship start acting in strange ways, even though they still have positive mass. Quantum fields change. Your chemical bonds become less stable. Negative mass doesn't pull you in. It pushes you away. You're not being pulled apart. You are taken away. It starts with feeling sick because your inner ear can't tell the difference between up and down. Then your skin starts to itch. Your hair starts to float around. And your image in a nearby panel moves in a way that doesn't match your movements. Soon, you'll feel your mass changing and your atoms becoming less stable. Your bones start to vibrate at the edge of existence, dancing with the anti-physics of this area where nothing is possible. After that, there was quiet. You fall down into yourself, not from gravity, but from anti-gravity, a localized collapse where the rules of motion are turned around, and you are turned into a mathematical paradox. From the outside, it looks like your ship stops and then disappears. Not burnt up. Not broken. I'm gone. If there are such places, tiny areas of negative mass that were formed in the early universe's chaos, they might be moving around the galaxy right now, not seen, not touchable, killing. It's not hot or cold or fast or slow here. It's not clear. You died not from being hit or burned, but from seeing a number less than 0 in a world that wasn't made to deal with it. In a universe this vast, death isn't just inevitable, it's unimaginably creative. From reality-shredding singularities to stars that kill with silence and light, the cosmos constantly reminds us how small, fragile, and wonderfully lucky we are to be alive. But while space may be trying to kill us in every conceivable way, it also invites us to understand it. So if you enjoyed this journey through the universe's deadliest corners, don't forget to like, subscribe, and share with a fellow stargazer. Because out here, curiosity might just be our greatest survival tool.